ever gotten a copy of the book? You only need volume 1 with you for now. But take both of them home, keep that volume 1. You want to go to page M1-8. Okay, so 4 sides. Yes, a square has to have 4 sides. So, is that a square with 4 sides?
Yeah. Well, no, because it could be a rectangle too.
Is that a rectangle?
Yeah. No, it is.
More like a trapezoid.
Not a trapezoid.
Parallel.
Not quite a parallelogram, because if it's a parallelogram, the opposite sides have to be what?
Parallel.
Parallel,
Hence the name.
right? Notice these sides are parallel, but those definitely are not. Okay, does anyone know the general name for a 4-sided shape?
Rhombus.
I don't know.
Not a rhombus.
A quadrilateral?
Ezra, I know I gave you one, but there's copies back there
Where?
on the back bookshelf, bud, or on the back counter. So, I heard someone say it, quadrilateral. You see that prefix quad? Anybody know what it means? 4. Lateral, meaning sides. Literally. That's what it is, 4 sides. So, I'm not asking about a quadrilateral, though, I'm asking about a square. So what other features up here need to be added in to make this a square? We need 4 right angles. All 4 angles of that quadrilateral needs to be right angles. So would this be a square?
No.
I got 4 angles though, 4 right angles.
Then no, they're perfect.
But it's still.
The sides aren't equal.
The sides need to all be the same
Like,
length, okay? And so what would the name of this quadrilateral be? A rectangle. But I need all of those sides to be the same length. And this isn't perfect. We're going to talk more about it later, but we actually kind of started to look at this. Does that look close to a square?
Yes.
Okay? We've already said that for that to be a square, all the sides need to have the same length. All 4 angles need to be
right?
right angles. And we started to get into a couple of the ideas earlier that, what about, would this be a parallelogram?
Yes.
To be a parallelogram, the opposite sides need to be
Parallel.
parallel. Are these parallel?
Yes.
Yes. Right, if I've drawn them perfectly, it would be parallel. Remember, that's the symbol we use for parallel. This would be the sign to show that these 2 sides are parallel. We use 2 instead of 1 there. All 4 angles need to be right angles. Does anyone know the symbol we use to show that 2 sides are congruent or the same length? Actually, we say it's the symbol for that they are congruent. Okay, so I need y'all to pay attention to this because I will use these symbols. This triangle, indicating parallel, to indicate that they are congruent, we use a tick like this. A single line like that goes through the side. It's perpendicular to the side. So if you see that, we're indicating that they are, what again? Congruent. We'll talk about the difference between congruent and equal in a second. But I will point this out. Ezra, what's wrong, bud? You need volume 1 and 2, Ezra. So go get volume 2 as well, but you need volume 1 and 2. Take volume 2 and leave it at home. You need volume 1 with you in class right now. Okay, I will point this out. These 2 sides, are they also congruent? Yes? Are they congruent to the other 2 sides? You already said if it's a square, all sides are, their lengths are all the same, right? So these are congruent as well. Okay, so those are all those different features. Opposite sides are parallel, got all that. Okay, so one thing I want to point out is this. We've talked pretty heavily about this idea in the past. Mathematics, at its core, is what?
The study of patterns and relationships.
Thank you, study of patterns and relationships. But for those patterns and relationships, we need a common, starts with an L, language. And we have to be careful with our language. Right here, all sides are equal. That's not quite mathematically accurate. We need to work on this. Does anyone know how we can improve this to make it more mathematically accurate? all what about the sides are equal?
All of
Lengths, right? We need to be careful about that, right? Because when we talk about things being equal, we're talking about numbers can be equal, right? What's the number associated with a line segment like this? It is the length. So when we talk about that, be careful and pay attention to the fact that if we're saying things are equal, we're talking about the lengths. Man, I can't put you to sleep that quick, Trent. Come on, man. Eyes up, eyes over here. If we need to move that group a little bit so it's rotated this way, then let's go for it. But guys, we're all of 10 minutes in the class. This stuff we've learned before. I know it's a recap, but it's important, especially this idea. I know many of us have a misunderstanding. It's not that the sides are equal. It's that the what of the sides are equal. The lengths. You've got to be careful with that language. All right. So let's get back into the lesson. Or get into the lesson a little bit more. So here's our agenda. We're going to wrap up a couple of small details with that getting started about squares, and then we're going to get into activities 1.1 and 1.2. I meant to update it. We should also get into 1.3 today. And so here's what all of this, that's not supposed to be there. All of this is about is understanding different lengths, or understanding how the coordinate grid works with geometry and how to think mathematically. Now, I need you all to pay attention to this, especially because some of us got very frustrated during that bivariate data unit. Everything is starting over. Everything is starting fresh. We're having a hard break from what we've been studying, so everyone has a very strong chance to be successful. I need you to trust me. I need you to do what I'm asking you to do. Meaning I need heads up. The second you put your head down, you're more inclined to fall asleep and not engage and not learn. Your head needs to be up and you need to be engaged. You need to actively collaborate. The more you talk, the easier it is to grow and to learn. All right. So here's what we're getting into is one, we've already started talking about this, key features of geometric figures. What geometric figure have we already looked at?
Square.
Squares. Have we talked about key features of squares? Yes, we're going to continue working on that. We're also going to be looking at informal and formal geometric reasoning. Our casual language versus actually being able to prove different things. And we're going to really get into that this lesson and next. Okay. And so we started talking about this a little bit earlier. Actually, we already did 1 and 2, didn't we? And we did 3. Okay, so we're actually on activity 1.1 now. So I need y'all to pay attention to this, because this is foundational to everything we're going to study. In a way, mathematical reasoning is not different from scientific reasoning. In science, what do? You do experiments, right? You study things. But when you do experiments, like, what's the first part of an experiment? You have to come up with a hypothesis. You got to observe something, really, to develop a hypothesis. And that hypothesis is you making a what?
An educated guess.
An educated guess or a prediction, right? And then in science, we make those predictions, and after we make predictions, we do experiments to collect data, evidence, which is part of the reason I need to do better about this moving forward, about how I approach the data side of geometry. But we're going to collect data, we're going to collect evidence to figure out if our prediction was right or wrong. That is what mathematical thinking is, at its core. We're going to make predictions based on data that we have, and we're going to test that prediction. Yes, sir?
Did we do getting started?
Yes, sir. We did that last Friday. Okay? So, in mathematics, right, you come up with educated guesses, and you test to see if they are correct. Notice your educated guesses are your informal reasoning, and we're going to move into the formal reasoning to actually check it. So, we're going to consider the diagram composed of 3 adjacent squares. 1, 2, and 3. Your job is to draw a line segment. So a couple of quick things to note. How would you read that statement right there? We should have seen this in middle school, but if not, I need to clarify this. Anybody know what that is? That's very close. Okay? One thing to be aware of is, does a line ever stop? No. A line continues forever. To show a line AG, you're going to do this. You see how it has the arrows to indicate that it goes for forever?
What is AG?
Not quite array, so what you see right here, we're going to talk more about this in a second, but you see how A is here and G is here? You're going to draw it in. So a ray has a starting point and then continues forever. So not talking about array. So it's not line AG, it's not array AG, it's only a piece of a line or a line segment. This would be read as line segment AG. So be aware of that. We're going to talk more about that moving forward. But you need to read this properly. Mathematics at its core is a language. So we are looking at line segment AG here. So from that, Wesley, how would I read this statement? No idea. Well, I'm coming back to you for the next one. Can I get a volunteer to read this one? Addison.
Line segment AF.
Line segment AF. Anybody want to push back on that or add on to that? Does that mean everyone's good with that? Okay, so Wesley, how am I going to read that? That's it, right? So line segments AG, AF, and AE. How would I read this statement?
Angle AGH.
Angle AGH. Alright? Remember, that means that G is the what of that angle? Starts with a V. Kind of. It starts with a V though. Not variable. Ooh. It's called a vertex. Right? It's the corner of the angle. It's called the vertex. So we'll talk more about this in a second. Okay, so we'll talk through some things, but here's the thing. If you're going to draw a line segment AG and AF, what do you probably need?
Protractor.
You could use a protractor. There's something else you can use.
Ruler.
A ruler. One person from each group, come up, grab a ruler for your entire group. So one person per group, come grab a ruler for your entire group. By the way, I will say you will need a protractor as well, so grab a protractor while you're up there as well. If you already have one, then you're good. Huh? But you like my rulers better? You don't like protractors better, but you like the ruler better? It's nice as well. Everybody will need their own ruler. Everybody will need their own protractor. If I need to get some more out, I believe I have some more. We actually will be using those as well today. Or maybe tomorrow. What? Is it the pencil part? We have plenty of those. Oh, then you need to use one of mine. Okay. Aiden, you can just leave it up there, it's cool. I'll just collect it later. Okay. So, draw your line segments A to G, A to F, and A to E. Go ahead and get those line segments drawn in there. You have your phone with you here today? I need you to go walk over to your phone and you should put a reminder in your phone to get your text book. Like put an alarm on there so that it goes off next time you say something to your brother. Okay, go put an alarm on there to go off so that you remember to get it from your brother. Go now. Go now.
Yeah.
Is that all that's left over there? I'll look. Share the protractors and just use the protractor. Here's a ruler right here. Ooh, that's got some gunk on it. You don't want to use that. You can use the protractor as a straight edge. So just do that for now. Okay. If you don't have your, okay, it looks like we all have it in there. Okay, at this point,
Who's supposed to do all
it
this?
says, say again.
Who's supposed to do all that and talk? Oh, never mind, that was a different one.
Okay, so label angle AGH with what letter? Actually, so let's do this really quickly. I want to draw this in here. I need something longer.
I forgot.
Can I get somebody to label A up here so that we can all check our answers? I need someone to come label A. Come on with it, Jordan. While he's labeling A up here, I need you each to label A for angle AGH, B for AFG, and C for AEF. Jordan, I thought you were coming up to label it. So, go ahead and label all three angles, complete number 1 for me. Check with your small group, see if there's any questions we need to ask. So in that diagram, I need letter A for angle AGH. Yep. Have we all labeled? I see some people in each group that have labeled it, but others have not even started to. Okay. Where's your A? Huh? Dude, it tells you like right here. Is it that you don't know how to do it? Hey, then that means you need to ask questions, dude. I cannot help you if you're not asking questions. What is this? That needs to go away while I'm teaching you math. Mister, I don't know what's going on, and then you're doing stuff that don't help me learn. Does that make sense? This is brand new, dude. It's literally activity 1.1. That's an excuse to say I don't know. No one knows. We're trying to figure this out. Yes, ma'am.
You're supposed to label it.
We're going to talk about it.
Label it A.
Thank you. Okay. Grab a seat. Hey, grab a seat. Grab a seat. Grab a seat. Why did you draw extra stuff? Why did you draw extra stuff? When did I ask you to draw anything extra? I said label angle A. Go grab a seat. Let's talk about it. All right. For those of y'all who were not sure, and listen, I need y'all to hear me very clearly on this. Nothing is going to frustrate me more than you sitting there and doing nothing. I'm not done going over this. I'm going to give you clarity on where different things should go. You need to at least try. I need you to at least try. Because I need you to think through it, or at least think about it a little bit before I have a whole class discussion about it. Now, at this point, let's discuss. It says angle AGH. Where would I start for angle AGH? At point A. Then where am I going to go? To G, and then to H. So I'm talking about this angle right here. So where am I going to put A? Right there. You can put it here or on the inside. Either one will work. That's angle A. Right? And we need to be careful about that because it needs to be inside of, does anyone remember what I called this point in the middle? The vertex. That A needs to be right there next to the vertex. Alright? So where is B going to go?
This as a straight line side.
So B is going to go right here, right beside it?
No.
To the right? Tell me when? Right there? Notice A to F to H, right? Or is it AFG? They use AFG. So A to F to G. So there's my B. Now I need C for A, E, F. So C would go right here. Any questions about that at this point? Feeling okay? Now, it says to use a protractor to measure those three angles. Now, I need you all to pay attention. Don't jump ahead because I want y'all to work on this as a small group together. But let's look at online. I found an online protractor to make this easier. Yes, sir?
I'm confused, like, how would you put A, G, B, and F, and C, T?
What?
How to put A to G, B to F, and C to E?
Well, no, they told me to put label angle AGH using the letter A. So I went to AGH, and so I labeled it using an A, based on the directions. Label AFG, so I went to AFG, and they said to use letter B.
Oh.
You good with that now?
Yes.
Notice I put it next to the vertex. Okay, I need y'all to pay attention to this. I went online, found an online protractor to explain very clearly, hopefully clearly, how to use this. First things first, you will either see a little hole or you'll see an intersection like this on your protractor. That needs to go on the vertex. First things first, the little T or hole needs to go on the vertex of whatever angle you're trying to measure. That's how you need to start. Make sure, notice, don't angle it like this. In general, that little hole or T needs to go on your vertex. Any questions about that? Feel like we can do that part? From there, you need to rotate your protractor so that the protractor is level with that side. So I want you to notice, right? Here is one side of the angle I'm trying to measure. One thing to clarify, I guess I should have said this. What I'm going to be measuring with y'all right now is AGE. So I'm going for this angle. Right there. And so, again, I put that T right on the vertex. I make sure that my side of the angle matches on, what number is this right here? 0. Notice how that also says 180? That's because if I was starting from this side, I'd be going around that way. Well, it is degrees, right? So notice this is the starting, it is 0 degrees. You have to make sure that one side lines up on a 0 degrees. From there, you go up to the angle that you're trying to measure. So it's kind of hard to see, but here's 20 degrees, right? So what, any guesses what this longer line right here in the middle is?
25.
So 25 plus 2 more would be 27. And so that's how I'm going to measure my angles. You may need to extend your line a little bit, right? But what I have, again, the hole goes on the vertex, one side is on the 0, and then I go around until I get to whatever angle it is. Now be careful, because how many numbers are actually right here?
A lot.
There's the 27, but also something a little more than 150. Remember, if it's more than 90 degrees, what's the name of that type of angle? Obtuse. Notice the obtuse angle is here. I don't want the obtuse angle. I don't want the one more than 90. I want the one less than 90. I want that acute angle. Is that language I need to clarify? Acute versus obtuse? Huh? I'm just making sure. Because I don't want to just assume that we know stuff and we don't.
Well, acute is a small one, obtuse.
It's not just small or big. Acute means it's between 0 and 90 degrees, right? Obtuse is between 90 and 180.
Would Ross do obtuse is like 360?
See, that doesn't fall under the category of obtuse.
What would that be?
It's just an angle beyond 180. The reason why acute and obtuse matter are for triangles, and triangles cannot have more than 180 degrees. Okay, so within your small groups, I want you to go through and I want you to measure those 3 angles to complete number 2. Write your answers down next to number 2. So it should be something like the measure. By the way, that symbol just means angle A. If you want to talk about the measure of angle A, you would do that. Measure of angle A equals measure of angle B equals. So write those out, find those angle measures. I'll come around and help you. But let's get to work. Hello? Yeah. Okay, she's on her way. Karia, you are checking out apparently. So, sorry, you might want to make sure you get these major ideas tonight. I'll post the videos as soon as possible.
Okay.
Have you measured your, you only have 2? Joey, where's your book? Why have you not gotten it out, man? Come on, dude. Well, let's get it out. Let someone else borrow your protractor for now. I'm going to try to find some more. Guys, I thought I had more protractors. I do not. Share if you do not have enough at your group, but work with each other. Yes, ma'am.
Okay, so I think yours is like with your one because I don't understand how much or how am I supposed to get mine? I can't see.
Which one are you trying to do? This one right here?
Oh, wait a minute, we doing it up.
So remember, there's your 0. Notice it says 180, but if you go far enough to the left, it says 0. So then go up to your angle there. Does that make sense what I'm asking? So remember that T needs to go right on the vertex. Let's line up with those. There it is. All right. And so follow this along until you find the angle. What does that look like it might be? Maybe 45? Y'all think about that? You agree? Yes, ma'am. Have you written out your angle measures yet? Come on, guys. Once you figure out one angle measure, write it out. Yeah, so that hole, yeah, you want your vertex in that hole. Now notice how this goes out to 0. Look over here. See how it says 0 degrees? So then follow it along until you get up to 0. Now you're going to have to kind of extend it just a little bit. What does it look like? Right.
On the
I mean, this, so if you want that angle, you just move over to here, and you should be able to see it pretty clearly there. Okay? And then so you might just have to use, you just have to kind of go a little bit over the book and do your best with what you got there. Figure it out. Extend it. A little bit less. Huh? That's supposed to make your life easier. So notice how the vertex goes in the circle, right? And then you see how this lines up with the 0? And then you literally just line that up. Man, look at how nice that is. Yeah, that's my favorite protractor that I have.
Yeah, I cut.
Have you tried to?
You put it on the L?
Where's your protractor? Oh my goodness, guys, I have a whole thing of protractors up here. Who doesn't have one?
I passed
And?
it
How many does your group need? 2?
I think it depends.
Your group and your group only.
I think it just Depends on our what you call it, or on how, yeah, on how our line is.
Dude, that one's way easier to use.
I got it.
I'll sit down and show you in a second. Who else needs one? Because they don't have a protractor. Anybody else? Jerry, come get one, bud. And then Ezra.
No, I got it.
When I ask who needs one, you need to speak up, dude.
This line right here, that's how you. The bottom.
Here, here. Huh?
He's asking if they're.
I mean, y'all should be working together. You should have similar answers. Don't just give them an answer.
Why do you keep getting that? I think, because I'm not
It's not gonna be productive.
Whatever line.
See how, again, that vertex goes inside the circle. You see how this zero needs to line up. And then the beauty of this is you have to line that line up, and it literally points to the angle. Right, so right there. So 27. That's way easier than that. Yes, sir.
She got 26.
Mhm.
So it's
Yeah.
different.
See how it has those lines there across? That's gonna line you up with your fingers. Alright guys, at this point we should, for the most part, have our three angles measured. Have your answers down. Look at number 3 to compare your measurements with your classmates' measurements. Talk about that within your small group once you have all 3 angles measured. Hold on, you be careful. So, can I see your... You said 153 here, right? This gives you what's right here. But remember, you're starting here at 0.
I got 27.
You need to go this side. That's the... So 26. Okay?
You were jumping.
Yeah.
You're good. I will say, if that's missing, it might be easier to use one of these. Because you need a smaller.
Look at the line.
You got our 3 angles? Have we noticed that? And
When you move the protractor, yeah, right.
hold on, how did you get 10? Show me. This angle A? Did you line it up like that? Remember, that vertex needs to be inside the circle, right? You see how the line is at 0? And then you want to find out what this angle measure is. So it's
But like when I do it, they're like close to my
what does it look like
line.
that might be?
Like for when I got 4C, I got 19 on mine. And I got 18 on yours.
40's here, that's all it is.
That was loud.
I think we'll say 40. Okay. So guys, we need to know how to use these protractors. Work within your small groups to figure this out. We gotta make, I'm coming around and checking, but we need to make sure we do this correctly. Wait, why are you ignoring him? He's trying to help you, is my guess. Alright, if you're not gonna answer me, then I'm not gonna help you either. Like, I can't help you if you're not trying. Are you just writing numbers down? But you didn't even draw your line segments.
No.
Have you read the directions? If you had your book out, you would have had number 1 already done. You can't do number 2 without number 1. You're sitting there on it. You got multiple people here who are going to be great resources for you to grow. But if you're not listening to them, they can't help you. Have you noticed anything? Wait, 444?
And you gave them that.
Did you mean to do 44 degrees? Would that make more sense? Okay.
You got M,
Measure of angle A.
There's no excuse that it was a hurt.
44, B is 27, C is 30.
Okay.
We notice that
Oh, turn it
keeps decreasing.
I think they said check, like, measure it yourself to check, but I think they said 19. Alright, yes ma'am.
Yeah, I got 26 for B and I'm in 19 for C. She got 19 for C and 27.
We need to be careful and check those. So like if I look right here, so let's be careful. Right, we need to make sure that's on 0, and then when I extend this out, see how it's like here? What does that look close to? There's 20, 25, 26. So that's my guess. Then same here, make sure it's lined up. And notice that's a little bit less than 20, maybe 18 or so. That's very close. Right? It's 27 versus 26, 19 and 19. That's very simple. Check those. It looks like you wrote down what someone else said. Thank you.
You told me that right here.
Thank
You
you.
told me, look right here. And I
Thank you.
put this.
Hold on.
Hey, you know, that you
Oh,
know,
then you didn't pay attention to your letters, my guy. Alright, sorry, I meant to say let's get started. 2 quick things to look at here. First off, did anybody notice anything about the measurements between your classmates and your own?
No.
Jamie?
The less the measurement is.
Right, so when we were here, I think I had the largest angle measure. This one had the next largest. This one has the next largest. Yeah? Anybody else notice anything else? Huh. Let me ask y'all this. Did anybody look to see, I don't know, what the sum of their angle measures might have been? Why don't y'all do this for me? Within your small groups, or on your own, add up your 3 angle measures. See if you notice anything about the sum of all those angle measures. Because we didn't necessarily all get the same. But I do want you to look at that sum. Look at the sum. By the way, mathematically, what do I mean by sum?
Add.
Add them? Okay. We got calculators for it. You got your sum? Came out to be 90. Now, be careful with your notation, because you just said the measure of angle C equals 19 equals 90. Is 19 equal 90? So you need to be careful about how you write it. So let's look at that in a second. Okay. And so let's hear some of those values. Anybody notice anything interesting?
Was an opposite angle.
How did you get that?
There's that hard together.
Okay, so when you added them together, what'd you get though?
I got 111.
Okay. Now I gotta ask though, did you actually measure your angles the way that everyone else did? Or did you just write numbers down?
I didn't really do either. I didn't measure what I thought was the right way.
But you didn't even have your sides or your lengths drawn, did you? You never drew AG or AF or AH?
I didn't know how.
Joey, dude, I was there and people were trying to help you. I can't, you can't say that I didn't know how. You're choosing not to. You can do it. I know you can. Nathan, what did you notice?
That the sum was 90, and 90 is the degrees for our right angle.
Okay. Did everyone in your group get 90? Raise your hand if you got a sum of 90. Anybody else get close to 90? What'd you get, Kyla? 89, 89. Anybody get 91? What'd you get? You got 88 as well? You got 93?
I got 91.
91? Hey, listen. Okay, so tell me, so raise your hand if you got between 85 and 95. A good chunk of us. A whole bunch of us.
We got both.
So let's make a prediction. What do you think the sum of those three angles is supposed to be? It's supposed to be 90. Sorry. So, will there be some error when we try to measure these things? Yeah, are we perfect at measuring these things? No. But if you did not get close to 90, you need to check again. We're going to get another opportunity in a second. But I will point this out. For anyone who did not get this angle 100%, check it. What's the sum, or what's this full angle from HGB? That's what kind of angle?
Right.
It's a right angle, so its angle measure is 90, right?
Which angle?
This HGB is 90 degrees. It's a square, right?
Yeah.
Isn't this cutting that 90 in half?
Yeah.
So what should the angle measure be?
35.
Half of 90 is? 45.
Close enough.
No, 35 and 45 are way too different. You say close enough. 44 would have been close enough. 43 would have been close enough. 46 maybe, but it is 45. That's 45 degrees right there. I think with angle B, you should have gotten somewhere around 26, 27 degrees.
I got 26, that's good.
Right? So that should be about 26 degrees or 27 degrees, somewhere in there. And then C, I think I saw 18 and 19 is the most common. And so that should definitely be 45 degrees. This should be that 26 degrees or 27 degrees. And measure of angle C. By the way, I don't know why my teachers did this. Sometimes you'll see me put an angle and put a circular arc through it. You don't have to stress that. You can just put M, the angle, and then B. But measure of angle C was 18 or 19 degrees. Does anyone see a symbol that I'm including up here that you might have forgotten that we need to not forget?
The degrees.
The degree symbol. If you are talking about an angle measure, you need to put a what?
Degree.
Degree symbol. That's how we measure angles, is with degrees.
Basically like you're measuring temperatures but without the F or the C.
Right. But, well, there's also another unit that you'll learn about probably next year called Kelvin that you can use as well. Okay? Thank you. All right, so comparing your measurements, what we want to know is that the sum appears to be what? 90. So how can I write the sum of three angle measures? Anyone know? Algebraically, how I'd write that out? Okay, well, one, what's a sum? Adding. How am I going to represent the measure of angle A? But you're not going to write A, you're going to write the measure of angle A. Notice I read that out every time. This is a simple way to write it, but Thomas, how would I read this statement right here? What did Jordan say? Measure of angle A plus, so Thomas, how would I read this part?
Measure of angle.
And plus measure of angle B, right? So Keandre, how would I read this part? Dog, we just had two of these. You haven't even tried. Come on. You intelligent? You capable? Yeah? So come on, give it a try for us. What does this M stand for? Oh, okay. And then that thing right here is an... What's this? Okay, so Thomas, can you read this for us again?
Measure of angle.
Measure of angle B. So Keandre, what would this be? Measure.
C.
There it is. And so what are we doing with those three measures? We are adding them. And the sum of those three angles would be 90 degrees. Don't just say 90. It is 90 degrees. You got that down, Thomas? Or not Thomas, Wesley? Come on. Now, this is only one case. Do we know this for certain?
No.
This is always true. Right? We've only done what's called informal logic. We're going to get into what's called more formal logic next. So here's one thing I do want to point out. This is in your book. Anytime you see something bolded, pay attention to it. Mathematics at its core is a language for patterns and relationships. We need to pay attention to the language here. When you sketch a geometric figure, you create the figure without tools. Accuracy doesn't matter. But if I ask you to draw a figure, you're going to use tools like straight edges and protractors and compasses to make accurate drawings.
I can't draw.
Well, good thing that we're going to be using straight edges and protractors and compasses.
What is
Because,
straight edge?
what does it sound like, man?
I don't know.
Come on, use your context clues. Literally, it's called a straight edge.
Edge.
Edge, that is?
Straight.
Okay. So where can we see edges that are straight?
Right angle.
On what? Say it one more time. Yeah, on a notebook, but like what's a resource I have in class that you can see a straight edge on? A ruler? Or maybe the side of that protractor?
I thought it was some kind of stencil.
Nope. It's just a straight edge. Okay? So, we're going to use rulers, protractors, the coordinate plane, compasses, different things like that to really make sure that we draw these things accurately, and we're going to learn about that today. So here is activity 1.2, making conjectures. So we're going to consider another diagram. I want you to notice, does this look very similar to what we just were looking at?
Yeah.
What's the difference?
They're already drawn for us.
They are already drawn for us, but what else? They're already labeled, but there's something else. Look at this set of 3 squares versus the last one. What's different?
The place there, they're already there.
Yeah?
Yeah, bigger.
Say it again. And what do you say, Ethan?
Oh, well, they're bigger.
They're bigger, right? Notice it says that in the directions, I believe. 3 differently sized, adjacent, and congruent squares. So these are all what? Y'all said it? A couple of people said it?
Congruent.
Yes, but these squares versus the last ones, these are
Bigger.
bigger. So without measuring, do you think the size of the squares will affect the sum of the measures of angles A, B, and C?
Yeah.
Yes? No? So here's the thing, we don't have to know. Remember how we said this is a lot like science where we're going to make a prediction? Write down your educated guess. Identify, do you think it's going to make it bigger or not? And just write out your reasoning why. I need you to think more than anything else.
Why are we writing it down?
Number 1, bud. Where it has that question.
Box.
Have you answered number 1 yet? Thank you. Joey, why's your head down, man? It's been like 2 seconds. Thank you. Thank you. Thank you. Anybody else? Thank you. Thank you. Come on. We know what this means. When I start saying thank you, there we go. So just pause. You don't have to have a perfect answer. Let's talk about it. Does anybody have any ideas or reasonings that they want to share out? Jordan, you got an idea you want to share? What you got?
I think it is going to affect some of the measures because, you know, size kind of got something to do with numbers and stuff like that, so it could be just different numbers playing out period and stuff.
So like you're saying because there's a bigger size there, you think the angles might be a little bigger?
Yeah.
Maybe? Okay. Any other ideas? Joey, you want to share an idea?
I just don't think it is.
Do you have any reasoning for that?
No.
Okay.
Like that.
Any other educated guesses? Maddie?
My
I
bad.
said yes because the wind. Because of the wind.
Okay, again, because the lengths are bigger, so the measure's gonna be bigger. Okay, so we have some educated guesses. Now we need to collect what? Data or evidence, one way or the other. So, in the previous activity, right, you may have noticed that the sum of the measures of angles A, B, oh wait, is this supposed to be, oh that's actually before, my bad. So Jada said the size of the squares doesn't matter. Given any three adjacent and congruent squares, if the diagonals are drawn in the same way, the sum of the angle measures will always be 90. So that's what Jada was thinking. Y'all were kind of thinking the opposite. Well, let's find out who was right. Notice the mathematical term for that educated prediction is a what? Conjecture. If you are making an educated guess, an educated prediction, that's a conjecture. It appears to be true, but we have not formally proved it yet. Going from informal logic to formal logic. Jamie,
I agree with Jada.
you think with Jada? Okay. Any reasoning?
Because, just because the shape is bigger isn't gonna affect the angle degree.
Okay.
Because you're starting at the same point, and you're still measuring from the same point.
Okay. So where you're starting and ending, it's not really changing, so maybe the angles are the same.
So you
Okay.
agree with me or no?
She's agreeing with Jada in that gray box there. So I'm not going to add anything else yet. I just want to see what your predictions are. We'll talk about it. So use a protractor to test your prediction on these differently sized squares. So let's find the measures of angles A, B, and C, and let's test out those predictions. I will say, can I do this real quick? If I were y'all, please note, like, this is in the book right now. You can either flatten it out or remember. Can you tear these pages out of these books?
Yes, you can.
These are perforated. Be careful if you want, but you can tear it out and you can just put it into a notebook, okay? That will make these measurement things much easier on you. If you don't want to, you don't have to. But let's measure those angles. Let's get it going.
He was wrong.
Say again.
That's
Hey, have you done your measurements yet, Jordan?
But A, okay.
Come on, let's measure those angles. We got some practice in. Hey, Benaya, have you done this yet? I'm glad you're enjoying drawing on the desk, but I need you to do this math first. You gotta be careful, Thomas. And make sure that y'all are working with Janiyah, because she wasn't even started on this. Check in with each other before you get too far. See if you're seeing the same thing. Actively collaborate. This is fine. You just make sure you tear it out. Be careful. Okay? But in the future, what I find out is to make it easier to tear these out, you want to just kind of lightly pull.
You know what I mean.
You see how easily that pulls out? Look at that. You never torn it out of your life like that before. That's how you gonna do it.
How you gonna get C? Put your protractor there. How you gonna get C?
No. Okay. Hey, if I can, just to show you all this really quickly, I do want to show you all how to easily tear these out. I know this sounds goofy, but if you want to tear this out without ripping, put your hand on either page. Actually, it's easier when it's on this side. Put your hand on either page and just lightly pull, and it'll easily tear out. Don't rip. Put your hand there and lightly pull away, and it'll tear out easily without ripping. Yes, Jordan. Yeah, I'm coming.
Alrighty.
Yes, sir.
So I tear up.
Okay. You that said that earlier, I would help you.
What?
You're trying to focus when you don't know what you're doing. It's not focusing. Like you want to have it go here. Like I've seen Devin help a lot of
Guess
people.
what you got?
Devin will help, and I've seen Emily help a lot of people, and they will help.
I got
So,
27. For G, I got 27.
oh, right here. And Joey, now I will say one reason I am a little frustrated is, do you remember when I did this on the board earlier with the projector? Because you weren't paying attention when I was teaching this
And
earlier.
then,
I need you paying attention when I teach you. That's an excuse.
how you doing it like that?
I'm
Without
being
without ripping it?
My point is, that we gotta find that. So you want, and if I'm talking, I know I'm allowed to pay you. You want that corner to be right on the vertex. You want one side to be here where it says 0. Okay? And then you come around until you get to that line. What angle measure is that? There's 40, yep, that's 45. Same thing over here. I want it on 0, right? The other one 0. Then I come around until it hits the line. What does that look like? That's 30, 29, 28, maybe 27. That's it. Do your last one. Thank you. Thank you. Thank you. For those who have been actively working, have we already gotten our 3 angles, or do we need a little bit more time? We got all 3? Perfect. Emily, you still working on it?
Oh, no, I got it.
Okay, cool. So using a protractor to test your prediction on these differently sized squares, what happened with those angles? Were they the same? The sum was still either at or very close to what? 90. Notice how we've now collected more evidence. Do you think it matters how big those squares are? No. The sum of those 3 angles will always add up to be 90. And so this is an important thing to note, and hear me very clearly on this. If you make a shape bigger or a shape smaller, do you think that's going to affect the angle measure?
Yeah, no, yeah.
I mean, at least so far, has making it bigger or smaller affected the angle measure? No. Then wasn't the sum still 90?
No.
I thought everyone else said that the sum of their angles was 90 or at least close to 90.
One was a 90.
The sum of all 3?
Oh, the sum of all 3.
You got 45 and 27, and what was the third angle? Okay, when you add all 3 of those together, what do you get?
88.
So were you really close to 90? How far is 88 from 90? Okay, is that close to 90?
Well, earlier I said 35, but 45, you disagree, so.
Joe, the difference between 2 and 10 is a lot. Okay, so 88 is pretty close to 90. You were just a little off on your measurements. So using a protractor to test your prediction on these differently sized squares, what do we find out? That it's roughly the same. I'm not writing this down, but you should have it written down. You should have your 3 angle measures there. You should have the note that the sum of those 3 angles is still 90 or at least close to 90. It's supposed to be, if you did everything perfectly, it is what?
88.
Still 90.
Still 90. It's supposed to be 90.
I got 88.
But it's supposed to be 90. You may be off a little bit on your measurements, but it's supposed to be 90. Okay? The sum of those 3 measures is still 90. Sorry, I wrote the degrees. You're right though. Alright, it is still 90 degrees. Thank you, Peyton, for calling me out. It's got to be degrees. So let's look here at number 3. This is something we want to get to because here's the thing. We've now seen twice that the sum of those angles has been what? 90. Now we're going to get into more formal things where we are visualizing how we could see this. So it says copy each of the angles A, B, and C from the diagram onto a different piece of patty paper. That means you need how many pieces of patty paper each?
What's that?
This stuff. Remember, you need 1 for each angle measure. So you each need 3, okay? So, 1, 2, 3. One person from each group get 3 pieces of patty paper for each person at your group. Come on. 1 person per group. Come get patty paper for the people at your group. Okay? So 1 person per group, get a sheet of patty paper for everybody at your group. Just write down what I've written on the board. You haven't even written down a single thing I've said. Yeah. Oh, you wrote yes. You put 3 letters down. Wait, we've been in here for almost an hour and a half. Yes, sir. Say again. You each need 3 sheets of paper, guys. Each one in your group needs 3 sheets of paper for now. Okay, eyes and ears up here.